Question 1. Rewrite 4,900,000,000 and 0.00000063 in scientific notation. So the first thing we need to remember is what scientific notation is. If we have a number of this kind of form, then scientific notation will be of the form a, which is some number, times 10 to the x, where an x is a certain number of places. So just to kind of show you how this works, we'll go through these problems. We have 4, 9, 0, 0, 0, 0, 0, 0, 0, 0, sorry, 3 zeros there. Hard to keep track. We can rewrite this as 4.9 because we're just going to take the first couple of digits, and the only two significant digits are 4 and 9. So 4.9 times 10 to some exponent x. Now what is x? Well, it's the number of places that we have to move the decimal over in order to fill out this number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So it's going to be 4.9 times 10 to the 9. Now, this is literally the number that is this, right? If we multiply 4.9 times 10 to the 9th, we're going to get 4,900,000,000. You can see the value in having scientific notation. This is a lot easier and simple to write than writing out all of these zeros. Moving on to the second one, we have, let me just make sure I get all of the zeros, right? This is 1, 2, 3, 4, 5, sorry, 1, 2, 3, 4, 5 zeros. So that's, yeah, it's so hard to see that. Okay. So this can be rewritten in the same sort of way. We're going to take the two significant digits, 6 and 3. So we'll rewrite it as 6.3. Usually you only want one non-decimal value, right? Like we had 4 here and we have 6 here. And we're going to multiply it times 10 to some value. Now, because this is a really, really small number, it's going to be negative. And we're still going to count it to places. So we have 1, 2, 3, 4, 5, 6. So it's going to be to the negative 6. And again, this is literally the same number as this. If we multiply 6.3 times 10 to the negative 6, we will get 0.000063. So this is how you would do a problem like this. And really, this becomes even more valuable the larger or smaller the number becomes. It's just a lot easier to write out, this number as this value in scientific notation. So it's just a standard, but it's very helpful to know. Moving on to question 2, we're going to find the negative absolute value of negative 4, the absolute value of 6 minus 9, and the absolute value of negative 4 times 5. So the first thing to do is to remember what the absolute value actually does. If we have some number a, the absolute value of a is always going to be positive, right? So whether we have the absolute value of a or the absolute value of negative a, this is always going to give us a. It basically takes whatever value you have and just makes it positive. So as an example, the negative absolute value of negative 4, we can rewrite as the negative of 4, because this negative 4 here is going to be just 4 when taken as the absolute value. So we're going to have negative 4, and we can drop the parentheses, and this just gives us minus 4. For the absolute value of 6 minus 9, we can just perform standard arithmetic within it. So we get the absolute value of negative 3, because 6 minus 9 is negative 3. And then since this is a negative, when we take the absolute value of it, it's going to give us the positive value of whatever is inside. So the absolute value of negative 3 just gives us 3. Likewise, we can perform multiplication within the absolute value sign. Negative 4 times 5 is within the absolute value sign is the same thing as negative 20, because 4 times 5, or negative 4 times 5 is negative 20. And then when we take the absolute value of negative 20, we just get 20. So this is a simple problem set to do, but you just have to remember what the absolute value sign actually does. Question 3. Take the reciprocal of 12, 2/13, and 2x divided by 3x minus 1. This is, again, another definitional type thing. If you remember what reciprocal means, then it's a very simple question to solve. The reciprocal is simply flipping. So if we have some fraction a over b, the reciprocal of this would be b over a. You basically just take whatever you have and flip it. So for 12, we can rewrite 12 as 12 over 1, right? Because it's a whole number. And so when you take the reciprocal of that, it's just going to be 1 over 12. Likewise for 2 over 13ths, or 2 over 13 rather, we can take the reciprocal of this, and this just gives us 13 over 2. And then even for abstract concepts like x, for 2x divided by 3x minus 1, the reciprocal of this is just 3x minus 1 divided by 2. Sorry, 2x. So this is how you would go about solving a problem like this. Thanks for watching.